Okay, जी, complex number. Let's start off with lecture number 7. Now, the most important part here is for you to understand is the table for trigonometric form. Let's say we have complex number, then we will have its modulus, how to find modulus, and how to find the argument. That means the angle for that. Let's just work upon it. If I say that we have Z1, so modulus of Z1 is equal to R1, and argument of Z1 is basically theta 1. If we have Z2, that means modulus of Z2 will be R2, argument of Z2 should be theta 2. So now what you need to understand is if two modulus are being multiplied, so what we can have is we can directly multiply Z1 multiplied by Z2, which means R1 multiplied by R2. That means your modulus can be multiplied to achieve the modulus of two different modulus being multiplied to each other. That means two different complex number being multiplied to each other. And with the same arc, if we need to find the argument of Z1 and Z2, so what we need to do is theta 1 plus theta 2. That means angle of Z1 plus angle of Z2. If we add them together, we will get the angle of the new complex number, which is Z1 and Z2. If we have Z1 divided by Z2, then that means Z1 divided by Z2, your modulus will be R1 divided by R2. And your theta argument will be theta 1 minus theta 2. That means if the two complex number are being divided, their modulus will be divided, whereas their angle will be subtracted. Similarly, if we have z to the power n, so what we can do is R1, Z1 to the power n, we can have R1 to the power n, and n can be multiplied by theta. If we have Z1 to the power -1, so there should be R1 to the power -1, and your angle will be in negative. If Z1 power is n, let's say -n, so R1 will be -n, power will be -n, and obviously -n will be multiplied with the theta. So these are the few forms of trigonometry when two modulus are being multiplied and divided, and when the modulus has power. This is exactly the same formula that is created for trigonometry to the power n, which means r to the power n, your cos n theta plus iota sine n theta is particularly used. So this is your normal formula when the z is being used for more powers. Let's say if we just have z1 multiplied by z2, and z1 is 2 plus 2 iota, and z2 is minus under root 3 plus iota. So in this situation, what we need to do is, if we multiply z1 multiplied by z2, so what we'll have is 2 plus 2 iota multiplied by minus under root 3 plus iota. So if we just solve this together, this will be minus 2 under root 3 plus 2 iota plus, I would say, minus 2 under root 3 iota minus, this should be iota square, so this should be -2. The end result that we will have is of z1 into z2 will be minus 2 under root 3 plus iota. Obviously, so this should be, let's take iota as common. This is 2 minus 2 under root 3. So solving this thing out, minus 5.46 minus 1.46 iota. If we just take the modulus of z1 into z2, so the modulus will be under root 5.46 whole square plus 1.46 whole square. The modulus is 5.65. And if you want to take the argument of z1 multiplied by z2, this should be because of the negative sign, which means this is what? Third quadrant. And the third quadrant had negative pi minus alpha. This is the form of the third quadrant angle. So if I want to find out the angle itself, the angle will be 10 inverse 1.46 upon 5.46. So in the other regard, it should be negative pi minus 10 inverse 1.46 upon 5.46. So the end result of this would be negative 2.88. So if I need to write down this thing in the trigonometric form, this should be z1 multiplied by z2 should be 5.65 cos 2.88 negative plus iota sine negative 2.88. Negative 2.88. So this is the form to write it in the trigonometric way. The other way to do this is that we can eventually find out using what? Using the modulus of z1 and modulus of z2, and then we can always have what? z1 r1 multiplied by r2. We can also have the modulus of r1 and r2 using the direct method. If I just work upon this thing that, let's say we have z1 as 2 plus 2 iota and z2 is minus under root plus 3 iota. So what we can do is z1 was 2 plus 2 iota, r is 2 under root 2, and the theta of this is pi upon 4. So what we can write down this thing is cos pi upon 4 plus iota sine pi upon 4. Similar way, we can also have z2. The modulus of this is 2, and the angle of this will be 5 upon 6 pi plus iota sine pi upon 6, 5 upon 6 pi. Now, what we need to understand is that argument of z1 is pi upon 4 and argument of z2 is 5 pi upon 6. If I want to have z1 into z2, so we can always have r1 into r2 or modulus of z1 multiplied by modulus of z2. So the modulus of z1 was 2 under root 2 and the modulus of z2 was 2. So the answer is 4 under root 2. Similarly, if we understand that if we have argument of z1 is pi upon 4, argument of z2 is 5 upon 6 pi, and we are told to find out the argand. So the angles will be added, which means pi upon 4 plus 5 upon 6 pi, which in the end we will have 13 upon 12 pi. So here's another question that we have z1 upon z3. If we work upon this, we can have 2 plus 2 iota upon negative 1, negative 3 iota. Multiply by negative 1 plus under root 3 iota, negative 1 plus under root 3 iota. If we just solve this thing, we will end up having what? Negative 1.366 plus iota 0.366. This is rationalization of the complex number. Now moving on, if we just find out the modulus of Z1 upon Z3, which will be under root negative 1.366 whole square plus 0.366 whole square. We'll end up having 1.414. And if we see that this comes under the second quadrant, and the second quadrant angle is always as in pi minus alpha. But to find out alpha, we apply tan inverse 0.366 minus 1.366. So if we just multiply the answer with pi, so the end result we will have is 2.88. So if we just write down this thing in the trigonometric form, there should be 1.41 cos 2.88 plus iota sine 2.88. Now let's work on the square roots concept. If you just see that we have two square roots, under root 5 minus 12 iota and under root 3 plus 4 iota, right? So the answer of this is 3 minus 2 iota and minus 3 plus 2 iota, where the answer for this is 2 plus iota and minus 2 minus iota. So if we just look at this, let's just solve the first one. The answer of the first one is 3 minus 2 iota. So 3 minus 2 iota comes here and minus 3 plus 2 iota comes here. So whenever you are solving the square root of complex number, it will always be diagonal, which means if I need to find out the angle, this angle gives me pi minus alpha, whereas this angle gives me minus alpha of every square root. If we have the second one, if we just see that the answer of this is 2 plus iota comes here, minus 2 minus iota comes here. So if it's in the first quadrant, the conjugate of this will come in the third quadrant. And for this, the answer for this is what angle is itself will be given as what? Alpha. And for this, we will be doing minus pi minus alpha. So whenever we have square root, considering that if we have 3 minus 2 iota and 3 minus 2 iota comes under the fourth quadrant, so we need to understand that second conjugate of this will come under the second quadrant. If 2 plus iota was in the first quadrant, then the second conjugate will come in the third quadrant. So this is normal concept of the conjugate given when we have a square root of the complex number.